in I.
Yes, sir. From that onwards.
Page number
25, sir.
what is the difference between the eye lens and a lab and a lab?
Sir?
This is the lens, right, in the eye.
Yes, sir.
So what is the difference between this lens
Hmm.
and this lab lens? You know what's a lab lens, right? School you have
Yes,
some
sir.
lab, something should be there, right?
Yes.
So this lens, what is the difference between this lens made of glass and
Hmm.
this lens, bio lens?
Hmm.
What is the difference?
Those our lens are convex lens and those lab lens are concave, sir.
We can have converse also in lab, right? See, lens
Ah.
formula is 1 by U
Hmm.
plus 1 by V equal to
Hmm.
1 by F. Is this correct?
Yes, sir.
This should be minus in here. Mirror equation is 1 by U plus 1 by U equal to 1 by F.
Hmm.
For lens, there will be a minus with the U.
Hmm.
Okay, so the way to remember is for a convex lens, the
Hmm.
origin of the x-axis in the middle. Okay, and
Hmm.
the positive direction of the x-axis object will be here. Okay,
Hmm.
this is the direction of the incident light, right? So the positive direction
Yes,
will
sir.
match the direction of the incident light. So the object is on the left side, so U
Hmm.
is less than 0. Usually the image will be on the right side,
Hmm.
and the focus on the right side.
Hmm.
So all these terms have to be positive. So to make this thing positive, I put a minus sign here.
Okay, sir.
That way you can remember. But in the case of
Hmm.
mirror, take the concave mirror, the object
Hmm.
will be here, image will be inverted here. Okay, so
Hmm.
U is negative, V is
Hmm.
negative, and F is also negative because the focal point is here.
Hmm.
Okay, so to make everything positive, I'll make like this 1 by minus U plus 1 by minus V go to 1 by minus F and cancel this negative sign throughout. We'll get 1 by U plus 1 by V equal to 1 by F.
Hmm.
Okay, so this way you can remember
Hmm.
the sign. Is that clear?
Hmm.
Okay,
Yes, sir.
so there are three variables, right, in this equation,
Hmm.
U, V, and F, correct?
Yes, sir.
So
Yes, sir.
if I fix two of them, can I change the third
Hmm.
one?
Yes, we can.
No. Suppose A plus B equal to C. Suppose I fix B to 2 and then C to 7. What is A then?
Um,
5, right?
5, sir.
So
Ah.
that's also fixed. But
Hmm.
suppose I fix only one of them, say
Hmm.
C as 7. Okay,
Hmm.
so then I can change A as different combinations, right? A can be 1,
Yes.
this 6, or it can be 2, 5, like that.
Ah.
Okay, so in the case of the lab lens, the focal length is fixed because it's a rigid surface. No, once
Yes,
the
sir.
lens curvature is fixed, focal length is fixed.
Hmm.
Okay, so U and V can
Ah.
change. These two are
Ah.
variable. But in the case of a eye lens, what is fixed? Is the focal length fixed? Actually, this is a
Yes.
flexible lens.
Hmm.
So it can become fat or it can become thin. Okay, that way the focal length is variable. What is fixed here? The distance between the lens and the screen. V.
Hmm.
You cannot change, no, unless you damage the eyeball. Okay.
Okay, sir.
So here V is fixed. So U and F can change. So
Ah.
F is changing because it's a flexible lens.
Okay.
Okay. So that's why this eye lens has to work properly. Like if you're watching
Ah.
far away, the focus has to be different
Hmm.
because U is large.
Hmm.
So V, uh, uh, V is fixed. So F has to be uh,
Hmm.
U is large.
Effects to be fixed.
F should match with V. U
Ah.
is having this term will go. So 1 by V
Hmm.
equal 1. So focal length should. So as you decrease U,
Hmm.
okay, the focal length has to change because V is fixed.
Okay.
Decrease U means decrease minus U because positive quantity is minus U
Mm.
because U is negative. So in mere object
Mm.
distance minus U. So
Okay.
the eye can adjust. So this focal adjustment of this focal length will have some limitations, right? So this focal
Yes,
length,
sir.
it can adjust to see objects from infinity to 25 centimeters
Mm. Huh.
with a minus sign. Okay, this
Yes,
one
sir.
normal eye. But if this eye has some defect, then it can see only from say 100 meters
Mm.
to
Huh.
25 centimeter. Or some other
Okay,
eye
sir.
problem will be like from infinity can see, but nearby it can see only up to 50
Hmm.
because this focal cannot adjust beyond that. Normal
Okay.
eyes can adjust from here to here.
Hmm.
Okay, so to compensate for that, you put a specs here. Either you put a concave specs
Okay.
or you put a convex specs. So the combination of these two
Hmm.
will make it work. So the defect of the eye is happening because this focal is not able to adjust properly. That's called power of accommodation. The ability of the
Yes, sir. Hmm.
eye lens to focus means to change the focal length.
Hmm.
If it's variable, but it should vary properly to that
Huh.
maximum range. But the people who have defect, that range will be reduced. So to compensate for
Hmm.
that, we use a
Hmm.
specs.
Okay.
So changing focal length
Hmm.
help of ciliary muscles. So this is ciliary muscle, the one which is attached to this lens. So this thing is stretching it, the lens will become thin. Okay, if this muscle is say contracted, then
Yes, sir.
compress the lens
Yeah.
and become fatter lens.
Hmm.
So a lens like this and a thin
Huh.
lens, suppose this focal length is f1, this focal length is f2, which one is more, f1 or f2?
F2, sir.
No, f1 is more. Sorry,
Huh.
correct. F2 is more because of here the focal
Hmm.
point will be here.
Hmm.
Okay, here the focal point will be here nearby.
Oh.
F2
Okay,
is
sir.
more. But which lens is more powerful?
F1, sir.
Because the job of the lens is to bend the light. So whichever bends more, that is more powerful.
Okay.
Okay. If I replace in the limiting case, this thin lens will become a rectangular glass slab.
Huh.
So here there won't be
Okay,
any
sir.
focus. The focus will be at infinity.
Hmm.
Because it will be a parallel beam of light, which will never meet.
Hmm. Okay, sir.
Okay. So these are
Okay.
the two defects. One is the
Hmm.
infinity, the thing is visible, but the nearby can see up to 50. This is one defect. Okay.
Oh.
Another defect is
Huh.
it can't see infinity, can see up to say 10 meters. But nearby it can see up to
Okay.
25.
Huh.
Students usually have this defect, 25 to this,
Hmm.
because the problem the students have is
Hmm.
not able to see the board.
Okay.
Board is at a distance of say 10 meters or 5 meters or 8
Hmm.
meters. But they can read the book
Hmm.
without the specs.
Hmm.
Okay. Old people have this
Okay.
problem. They cannot read the book. Okay. But they can
Hmm.
see the faraway objects.
Okay.
But some people will have both difficulties. They can see only 100 meters and
Ah.
nearby they can see up to only 50
Hmm.
centimeters. 100 meter and
Okay, sir.
so this is both indeed so three defects.
Huh.
Okay.
Okay, sir.
Power point defects होता है. Myopia, short sightedness, you can see the nearby objects. That is student.
Hmm.
That way you can remember.
Huh.
Student cannot see the
Okay,
board.
sir.
So this is where the length of the
Hmm.
eyeball. Eyeball ideally should be spherical. But if it becomes like this
Oh.
or becomes like this,
Huh.
then it's a problem, right?
Hmm. Yes, sir.
So lengthening of the eyeball,
Hmm.
nearby objects seen clearly, but distant objects not seen.
Hmm.
Okay, this is the
Yes,
board,
sir.
board of the classroom.
Hmm.
Okay, so
Hmm.
okay, so the focal of the eye lens
Hmm.
is reduced, or the length of the lens
Uh.
retina increases. Then the
Mm.
Students wear concave lens because if you see the old people
Huh.
lens, no, when they wear the lens,
Yes.
their eye itself will be look bigger.
Ah.
No, see if you put concave lens and stand in
Yes,
front of
sir.
the mirror, you will not feel that much difference. But if you see people wearing convex lens, the old people, the eye itself will look big from the
Mm.
to the other people.
Mm.
Okay,
Yes,
so
sir.
students wear concave lens.
Hmm.
That way you can
Hmm.
remember.
Hmm.
This is basically the relation of 1 by equal to 1 by equal to 1 by f. So that will come.
Ah, sir.
So myopia calculated. So here, see, it's a elongated eyeball. So the image is forming here itself.
Hmm.
Actually,
Okay,
the
sir.
image should form in retina, right?
Yes, sir.
So this is a defective eye, myopia. Okay. So
Huh.
the image is forming here. So it's converging too much, right? If the lens is
Yes,
converging,
sir.
it will meet nearby. If it is converging less means it will be
Ah.
meeting far away.
Huh.
Okay. And so for this converging lens, if you send parallel beam, it's converging
Huh.
here. Okay. But if we send a divergent, slightly
Hmm.
divergent beam, they will meet here, right?
Huh.
Okay. So that divergence I'm getting by using a concave
Ah.
lens here.
Okay, sir.
So in some sense, this is over converging. To reduce the
Hmm.
convergence, I'll send a divergent light here. That's
Hmm.
done by the concave lens.
Okay, sir.
Okay. So I adjust the focal length of this lens so that the image forms at the retina.
Hmm. Hmm.
Okay. So the combination of these two, concave, the specs and the defective eye,
Huh.
it's equal to the
Huh.
normal. So
Okay,
this
sir.
combination produce the image of the retina.
Hmm.
Okay. Student have this myopia problem. So the image is
Huh.
forming and nearby. Okay. So it's over converging.
Huh.
So to reduce the convergence, put a concave lens, concave specs.
Okay. Okay, sir.
That way you can remember. And the other older people,
Hmm.
the other way around, the image is forming
Hmm.
beyond retina. So the convergence is less. So to increase the convergence,
Okay, sir.
put a
Hmm.
convex lens in front. So this is old people.
Hmm.
They cannot read the book,
Okay, sir.
okay, but they
Hmm.
can see the distant objects.
Hmm.
Okay. So here it's bifocal. Both the problems are there. So
Okay,
here
sir.
this lens in specs will be divided into two parts. Okay, the
Hmm.
lower part and the upper part. So for reading
Hmm.
book, they need use the lower part, right?
Yes, sir.
So this will be old people, that's convex. So
Okay,
this
sir.
for seeing the board for students, so that
Um.
is concave.
Hmm.
So this is bifocal lens.
Okay, sir.
Students have both the defects,
Hmm.
myopia as well as hypermetropia.
Hmm.
Okay. So upper part concave to correct myopia.
Hmm.
To remember is to see the board, you will see through the upper part of the lens. Understood, no?
Yes, sir.
Book will be
Ah.
down on your table. Table will be in the front, so you have to look up, right? Slightly up. Okay. So now you're
Okay,
seeing the
sir.
board, you see through the top part of the specs.
Huh.
So that is student problem. So it's concave lens. For reading the book, it's the problem of the old people. That is
Hmm.
convex lens.
Hmm. Okay, sir.
Okay. But some people will have both these
Ah.
defects from the young age itself.
Okay,
Okay.
sir.
That is this one.
Hmm.
So even old people also, or you can say the people with this, students with this defect, when they get old, they'll get this other problem also. So they have to use
Hmm.
bifocal.
Okay, sir.
So in addition to that,
Hmm.
astigmatism. This is because see, suppose even if the problem is there is another problem. Suppose you have an object like this, normal
Okay,
eye.
sir.
So this is the object.
Huh?
Normally the image will be rectangle,
Hmm.
Okay, but some defective eye, this square or rectangle
Hmm.
becomes this. Understood? No, curved.
Yes, sir.
Okay, so that problem is called astigmatism.
Ah,
But now, cannot see parallel or horizontal lines clearly.
yes, sir.
Structure of the eye lens. No, okay,
Hmm.
it's cylindrical lens.
Okay, sir.
See, lens is created by what?
Hmm.
You put two glass spheres.
Hmm.
It's sphere like a ball. Okay, and
Yes, sir.
then this intersecting part you keep it. Remove the other part. So this is convex lens. Understood? No,
Okay, sir.
two spheres.
Yes,
I can
sir.
also have two cylinders, intersecting cylinders.
Okay, sir.
Okay, and remove this part.
Hmm.
So this will give me a convex lens, but a cylindrical convex lens.
Hmm.
So for correcting this one, we need cylindrical.
Hmm. Okay, sir.
Normal lens is spherical lens default.
Hmm. Hmm.
Okay, so this is cylindrical lens. Again, it's a theoretical thing only, so just have to remember this one. So basically, you can say four defects. One is
Okay, sir.
short-sighted. Short-sighted means you can
Hmm.
see. Short-sighted means you can see nearby things,
Hmm.
but not far away things like the board. So it's a student problem. It's myopia. First one.
Hmm.
Second one, hypermetropia. It's a old
Okay,
age
sir.
problem. They cannot read
Hmm.
the book. Okay, so they need convex
Hmm.
lens. Third thing is combination of these two.
Ah.
Presbyphobia. So for this,
Hmm.
you need biconvex lens, bifocal lens, both concave and convex. So the top part will
Oh,
be concave, and the bottom part will be
ah.
convex. Because
Okay,
you
sir.
read the book from the bottom part and see the book through the top part. And the last defect is cylindrical lens. It's basically a rectangular square
Okay.
getting distorted as a curved figure. Okay, to correct that, you need cylindrical lens.
Okay,
Are there
sir.
problems in this one?
No, sir.
Okay, is it clear?
Yes, sir.
Uh, I would-
And then uh, that complex microscope, sir.
yeah, I'll go with this thing. So simple microscope, same as a lens, which you can buy in a
Hmm.
shop. Okay, just one single convex lens. Okay,
Hmm.
so the image will be enlarged, virtual and direct. So for a convex lens, if you place this, see, have this convex lens, okay, and suppose I'm
Hmm.
placing on top of this book, but the distance should not
Hmm.
be too far away. This object distance, that's u, should be less than the focal length. Because
Hmm.
for a convex lens, only when the object
Ah.
is between this focal length and the optical center, you will get
Ah.
divergent rays and it will be a virtual image on the left side.
Okay, sir.
Beyond focal point, there will be inverted image on the right side. It's a real image. I can catch it on a screen.
Hmm. Okay, sir.
But for magnification as a simple microscope, you will see the
Hmm.
virtual image.
Hmm.
Okay. So for that, the object has to be
Okay.
placed within the focal length.
Hmm.
Okay.
Okay, sir.
Here. So this is simple microscope. See here the focal point. Within the focal point, you're giving so that you create this image here. And actually,
Ah.
no, if you see, there is a convex lens within the eye, right? So
Yes,
this
sir.
image will produce a image on the retina of this eye. This is retina.
Hmm.
Okay.
Hmm.
So the distance between this and this should be
Ah.
25 centimeter
Hmm.
or more because eye cannot see objects within 25 centimeter.
It can be more than 25.
Yeah. Obviously, you can see it far away. No,
Okay.
the bus is coming far away, you can see. But if you take your hand
Yes, sir.
and take it too
Ah.
close, you cannot see anything.
Hmm.
Or
Yes,
take your
sir.
book and bring it too close, you cannot see the
Hmm.
letters, even if it's a normal eye.
Ah.
Okay. So this virtual
Okay.
whatever is forming should be at a distance of 25.
Hmm.
Okay, this simple microscope, just this one. Compound microscope just can combine two lenses.
Okay, sir.
So this first lens is producing a real image, okay, which is within the focal point of this second lens.
Okay.
So the eye will see whatever is coming from the second lens, and the lens which is close to the eye is called eye lens or eyepiece.
Okay, sir.
This is the object, the lens which is close to the object is objective lens.
Okay, sir.
Okay, so first thing, it's beyond the focal point. So the image will be real and inverted here, and this will come within the focal point of the second lens. This is FE, this is
Okay.
FO. Okay, so this FO is short because it's fatter lens. This is thin lens, so focal will be large. Okay,
Okay.
and this is inverted image, so you see the inverted image. Okay, so this is compound lens. Okay, so only, sorry, compound microscope. So two type of microscope, one is a simple and second one is compound. Telescope, see, for microscope, this distance will be finite distance. Like the microscope we have in the lab also, the whatever you want to see will be at a short distance.
Okay.
But if you want to see far away objects like the stars in the sky, their U is very large, no? U is infinity. Telescope. I didn't come. What is traveling microscope? Traveling microscope is one of the best instruments. Measuring small length.
Sir, I couldn't see your screen, sir.
Right. Now we can see on it.
No, sir.
Wait.
Okay, sir.
You can see now?
No, sir.
Just a minute.
Should I rejoin the class, sir?
Wait.
Okay, sir.
Now? Okay. So,
No,
okay.
sir.
What up? Is it visible or not?
No, sir.
Okay. Third one is there something like traveling microscope. One of the very small one. Right? Okay, you just read as a theory, but basically you can measure distances of 0.01 mm. See, obviously, if the scale is small, okay, you need a lens to magnify this, no? Whatever is reading is in scale. So for that also traveling microscope is used, measuring very small length of the order of 0.01 mm. You can hear, right? Now I think you can just log out, disconnect and completely, because it's showing multiple participants, but the mic is not on. Now the mic is on.
Okay, sir.
Okay. So what I was saying is traveling microscope. Okay. See, if the scale is small, readings, you need a lens, right, to magnify it. So this traveling microscope does something similar to that. So it's measuring very small lens of 0.01 mm. You know, 1 mm, right? It's the normal scale you have. That one division is 1 mm. So 0.01 is 100th of that.
Okay.
So such a small division, you need some sort of a microscope to magnify it, right?
Yes, sir.
That is traveling microscope. That much is enough. Okay, so telescope, the object is very far away. They are not. Yeah, there is a difference between telescope and microscope. Microscope, the object is nearby. It's on their table, and you have a microscope just above it at a very short distance. But telescope means the object is in the sky.
Okay.
So tele means large distance. Scope means it's within the scope. You can see it. Microscope means micro means very small, and you can see. So it's microscope. Telescope means tele is away. Scope,
Okay.
you can see it. Okay.
Mm.
So, see distant also. First telescope, okay. Kepler,
Mm.
also theoretical only. So reflecting telescope means you just use lenses. Sorry,
Mm.
refracting. So obviously lens will be there.
Okay.
Okay. Reflecting means mirror will be there.
Okay,
Reflecting.
sir.
Hmm. Astronomical telescope. Yeah. Even a terrestrial means Earth, but to see a far away object like
Mm.
a binocular,
Mm.
you need that's called telescope. Microscope is for seeing small things which are nearby, like on the lab table in the biology lab we would have seen, right? But telescope is like suppose you want to see something which is um, 10 houses far away. For that, you can use a telescope. That's terrestrial telescope. The one is
Okay,
using
sir.
with astronomers. You look at the sky. That's very, very far away.
Mm.
Here is U is very, very, very large compared to
Mm.
terrestrial. Here it's say finite, say 10 meters or something. Here it's infinity. Astronomical.
Mm. Okay, sir.
Heavenly bodies like star, planets, galaxies, etc. Terrestrial means it's on the Earth only, but it's far away distance.
Okay, sir.
Ah, problem is there. Myopia and okay, the person with myopia is this student. Okay, can see objects
Ah.
reach at a distance of 4 meters.
Mm.
So he wants to see. So far, board is like a distance of 20 meters. So for
Mm.
him, he can see from 25 centimeter to
Mm.
4 meter. Okay, but this has to improve to 25 centimeter to 20 meter.
20 meters. Mm.
Okay, so the the object which is at 20 meter
Mm.
from the specs, okay,
Mm.
should form a image. This is eye lens.
Mm.
Okay, so this is specs. Okay, so the image of this one should come to specs will be very short distance. So the image, the
Yes, sir.
first image should come here. Let me call it I1, first image. That should be a distance of 4 meters. Is
Mm.
that clear? The actual
Yes,
object
sir.
20 meters. Using the specs,
Ah.
I'll bring that image to 4 meters because this eye can see only from 4 meters.
Okay.
So for this concave lens, U is
Mm.
20. I'll put the sign. Okay. And V
Okay.
should be 4 meters.
4.
Okay.
Okay.
And the sign is minus, minus because both in the
Mm.
left side. Okay.
Mm.
So mirror lens equation 1 by minus U plus 1 by
Okay.
equal to 1 by F. So 1 by minus U is
Mm.
20 plus 1 by minus V is 1 by V is minus 4 equal
Mm.
to 1 by focal length is that's what you have to find out. So this
Mm.
is 20 minus 4,
Mm.
16 by
Mm.
20 into 4. So 4 times,
Mm.
it's 5. So focal length is minus 5
Mm.
meters.
Okay.
Otherwise, you can straight away use this formula, but this is the logic. Understood? No.
Okay.
Normal I can
Yes,
see
sir.
25 into 4 meters. Sorry, 25
Mm.
centimeters to large distance. But this
Mm.
defective eye is seeing from 25 to 4, but he's saying
Ah.
improve it to seeing from 25
Ah.
to 20.
Okay.
But he's not even bothering about 30 and off. At least he should see
Mm.
it up to 20. So for this 20 thing, correcting, so this 20 object should come to 4 meters. Then this
Mm.
I defective I can see. So that
Mm.
means for the specs, U is 20, V is 4, and specs and this
Mm.
distance is very small. Okay, so even if you say from the distance between the eye and the image is 4, the distance between the
Mm.
specs and the image is also 4 because this is around 5 centimeters or something, right? You can see, right? Specs is very close to the eye.
Yes, sir.
It's almost 0. Okay. So the distance between this eye and the specs is, image in the specs is same as this eye lens and the specs. So in the image first.
Okay, sir.
So for this specs, U is 20, V is 4, both on the left side. So it should be minus. Focal length for convex lenses on the left side only, so it's negative. That's why it's minus 4.
Okay, sir.
Because for a concave lens, if you send a parallel beam of light, it will diverge, right? So the focus
Yes,
is on
sir.
the left side. So focal length is negative for concave lens.
Okay, sir.
Okay. Next is this one, hypermetropia. So there is a voltage problem. So person, the near point is moved to 1.5 meter. So this eye can see from 1.5 meter to infinity. Normal eye is 25 centimeter to infinity. So, okay. So whatever is there is 1.5 centimeter, 1.5 meter, that's up to 25 centimeter. Sorry. Whatever is there, 25 centimeter should go to, because he can see from 1.5 meter to infinity. He cannot see 25 centimeters.
Yes, sir.
Okay. So U is 25 centimeter and V is 1.5 meter. Understood, no? So once
Yes,
V,
sir.
so this V will act as a U for the eye lens. Okay. Again, the same formula. So this is a convex lens because old age people. Okay. Both U and this are negative. So 1 by minus U, it's 1 by minus, it's 1 by plus 0.25 plus 1 by V, it's minus 1.5 equal to 1. Why is it plus 1.5? Because it's 1 by minus U. That is the formula.
Okay.
So 1.5 minus, so it's 1.25 by 0.25 into 1.5. So this is 5 times. So this is
Okay.
3 times. 3 times is 0.5. So 1 by 0.5. So focal length is 0.5 meters, 50 centimeter. I done something wrong.
Okay, sir.
The numbers are correct. Yeah.
Yes, sir.
This is wrong. 1.5 minus 0.25. It's 1.25 only. 1.25. 25. 0.25 4 times is how much? 5 times is this one. 5.
Yes, sir.
It's 0.5. This step is correct. 1.25 by product of these two. 0.25 4 times is 5 times. 0.3 only, correct only. I got 0.3 only, bro. Here.
Yes, sir.
Okay. Otherwise, you can straight away use the formula or you can use this logic, which I said. Normalize 25 to infinity. Okay. This normal case, but this defective eye is 1.5 to this one. So whatever is there at 25 centimeter should go to 1.5 meter. Not even this person
Okay,
can see.
sir.
So U is 25 for the specs centimeter and V is 1.5 meter.
Okay, sir.
And both will be minus sign. U is negative sign, that's clear. But V is, it's virtual only. So on the left side only.
Okay, sir.
So V is also negative. But the formula will have 1 by minus U. So this is an important problem. This will come.
Okay, sir.
This is a simple Snell's law. Okay, there is one confusion where you can get confused whether it's uh,
Hmm.
see in a denser medium.
Hmm.
Okay, take this interface air and glass. Okay, which one is denser for
The
light?
glass, sir.
Glass is denser. So if this is the
Hmm.
normal, if light comes like this,
Hmm.
it'll go
Hmm.
towards the normal, right?
Yes, sir.
So this is I, R. So R is less than I.
Yes, sir.
Okay, and the refractive index of this glass with respect here is greater than 1. It's 1.5.
Okay.
So it's the ratio of the two speeds, and speed here is more. So it should be velocity in air by velocity in glass. So this should be greater than 1, right?
Yes, sir.
So higher speed should come here.
Then that should be coming now, sir.
So it's velocity of air
Huh.
by velocity of glass.
Huh.
You might get, see here, the thing is different. Glass to air, here air to glass. So there is a confusion here. You might get confused.
Okay. Okay.
So to understand that confusion, you take this example of air glass.
Hmm.
The refractness are 1.5 and the velocity in
Hmm.
air is more. So the speed ratio should be air to glass and the
Okay.
refractness of glass with respect to air.
Huh.
Okay. So refractance of four substances are given. The speed of light.
Hmm.
So whichever is less dense, the speed will be maximum there. So speed will be maximum here
Okay.
because this is least dense. No,
Yes, sir.
refractness is the ratio of the thing. So if this thing
Hmm.
is decreased more means then the refractness will be more.
Hmm.
In air it is fixed. Okay. So if this
Okay.
ratio is more, then it's more dense.
Hmm.
Check the answer.
Ah. So this is minus 0.6, sir.
No, no. Which one?
Oh, sorry, sir. I'm in the wrong page, sir. 1 second.
Objective.